We'll get our homework on page 693 of our textbook on diffraction and interference of light. Question number 1 says, an unknown wavelength of light is incident on a diffraction grating with 2,500 lines per centimeter. What does this mean here, this lines per centimeter thing? Yep.
That's basically what I know over D.
Good. D is the distance between slits, distance between openings. So it's centimeters. You could say it's centimeters per line if you wanted to, right? Because it's centimeters in between lines or centimeters in between slits. We're talking about lines per centimeter here. So as Joshua just said, that's really the value of 1 over D. Now, we got to recognize that, because if we don't, we're going to end up making a mistake here, getting the question wrong. But when we do, it doesn't make it really much harder. We just have to flip it over to get the value of D and convert to meters. So the distance between the central antinode and the third dark node is 20 centimeters. Okay, that's going to be X, 20 centimeters. We're going to make that meters, 0.200 meters. And the screen is located 50 centimeters. That's going to be L from the grating, 0.500 meters. We got to make sure that N is consistent with X. The central antinode, first order, second order, third order, fourth order antinode. We're going from the central antinode to the third dark node. 1, 2, 3, third dark node. What's N going to be there? What is it? Good. N is going to be 2.5. And we're looking for the value of lambda. Now, this is a good question. We don't see one like this all that often, but it's a good question nevertheless. We want to use the equation lambda is equal to xd over n times L. There's two equations that apply to this situation. D sine theta over n, xd over n times L. This is the one that looks like it fits the givens the best, right? But there's a big if for that one. You guys remember when I gave you that equation that was the big if? What was the big if? Yep.
L is, it has to be greater than X.
Yeah.
It's not.
Yeah. Now, in the end here, the actual rule is theta less than 10 degrees. But our rule of thumb, so that we don't have to calculate theta every time, because that's a bit of a pain, our rule of thumb is to say, is L greater than 10 times X? What's the value of 10X here? 0 would be 2 meters, right? What's the value of L? 0.5 meters. Is L greater than 10 times X? No, it isn't. So for the first time, we've used our little trick here, our little rule of thumb to determine if we're allowed to use this equation. And we found that we're not allowed to use that equation because L is not greater than 10 times X. L is less than 10 times X and quite a bit less than 10 times X. So we're not allowed to use that equation. We got to use the other equation, but my problem is I don't know what theta is, and I need theta. So let's find it. This is X. This is L. This is theta. X is 0.200 meters. L is 0.5 meters. We can find theta by saying tan theta is equal to opposite over adjacent. And I think theta worked out to be 21 degrees or something like this. Anybody have it? 21.8 degrees. Now we can say lambda is equal to d sine theta over n. Use the equation that always applies regardless of what the angle is. Now, some of you may be thinking, well, I could have done that before. I could have found the angle in the first place rather than doing my little rule of thumb up here. Sure you could. You could find the angle every time if you want. But I think finding the angle is harder than multiplying x by 10. Okay? The rule of thumb, I think, is a good little rule of thumb. If it doesn't work out for us, then find the angle. But if it does work out for us, then we don't need to bother finding the angle. It saves us that little bit of work whenever L is not greater than 10, or whenever L is greater than 10 times X. In this case, it wasn't. We found the angle like we could have anyways, but we usually don't need to. Okay, D is, what is it? We don't know what D is. Let's find D. It's 1 over 2,500. Easiest way to do that on the calculator is just to say 2,500, x to the minus 1, gives me 4 times 10 to the minus 4. What are the units for that now? Centimeters. If I flipped over 1 over 2,500, then it's centimeters. Okay, listen carefully here. When you're finding the value of D, don't try to convert lines per centimeter to lines per meter. Don't do that. How do you convert centimeters to meters? Anybody know? Boy, I hope you do. You convert centimeters to meters by dividing by 100. You don't convert lines per centimeter to lines per meter divided by 100. There you'd have to multiply by 100 because centimeters is on the bottom. That's confusing, at least it is to me. To simple people like me, that's a little bit confusing. So to me, like, listen, just flip it over, get centimeters, and then let's convert to meters because we've done this a million times. Now we just divide by 100 and we get 4 times 10 to the minus 6 meters. That make sense? Do the conversion when you have centimeters, not lines per centimeter, because you're going to mess up on that. If I gave that problem to 10 of you, I guarantee you probably at least 5 of you would have messed that up if I said convert lines per centimeter to lines per meter. All right, D is 4 times 10 to the minus 6 times sine of 21.8 degrees over the value of n, which is 2.5, not 3, but 2.5. Now let's figure this one out here. We got 4 times 10 to the minus 6 times sine 21.8. Make sure you're in degree mode. Let's divide that by 2.5. We get 5.94 times 10 to the minus 7. Now I think the book had 6.4 or something like that times 10 to the minus 7 meters. So they ended up using this equation, and they used it correctly, except that it was not a valid equation. You can see how even an angle that's 21 degrees produces an answer that's quite a bit off when we use that equation, right? When we're under 10 degrees, we're getting close to 10 degrees, we may get a slightly different answer using that other equation, but it's still okay. Both would be marked correct. But over 10 degrees, the difference in them becomes significant enough that we say the first equation just isn't good enough for us. So then we want to use the second equation for sure. Number 2, we're looking for the lines per centimeter. Number 2, what are we looking for here? Lines per centimeter, what variable is that? It's not x, not L, it's not D, it's 1 over D. Good. So let's write down that we're looking for 1 over D, which is really not all that hard. Just find D and then flip it over. The third dark fringe from the central antinode, central bright spot, first bright spot, second bright spot. Probably shouldn't be drawing my bright spots as black. You think you get the idea there. Third dark one is 1, 2, 3. So n would be 2.5 there, from 0 to 2.5. 2.5 minus 0 is 2.5. X is 0.0500 meters. L is 0.60 meters. And lambda is 500 times 10 to the minus 9 meters. So let's get the value of D. Lambda is equal to D sine theta, lambda is equal to XD over N times L. Looks like the givens fit that equation. Let's just make sure that we're allowed to use that. It's the value of 10x, 0.5. L is 0.6. Oh, barely. Are we allowed to do it when it's a barely type thing? Sure, sure. We always, this rule of thumb errs on the side of caution, right? So even if 10x is almost the value of L, even if it's equal to the value of L, you're okay. Just don't do it if it's bigger than L. Okay, so we're going to use this. Let's solve for D. It becomes a lambda times N times L over X. Lambda is 500 times 10 to the minus 9 times N, which was, we said 2.5, times L over X, which is 0.05. So let's get the value of D there. 500 times 10 to the minus 9 times 2.5 times 0.6. Divide that by 0.05. 1.5 times 10 to the minus 5. and that's going to be in meters. So what are we going to flip that over? That's D in meters. You know what? We're actually going to convert that to centimeters before we flip it over because we're looking for the lines per centimeter. That's 1.5 times 10 to the negative 3 centimeters. Right, to go from centimeters to meters, divide by 100. From meters to centimeters, you would multiply by 100. So that's what I've done there, multiply that by 100, and now I'm going 1 over 1.5 times 10 to the minus 3. I'm going to flip that over, and I get this devilish question of, or this devilish answer of 666.6 or 667 lines per centimeter. All right, number 3, last one on this page, says the diffraction grating is 1,000 lines per centimeter. Always seems to be in centimeters, right? Red light, nanometers, is incident on a grating. What's the separation between bright antinodes on a screen 3 meters away? We're looking for the value of x, and we're going to say that the value of n is 1. When it says between bright antinodes, what they mean is bright antinodes that are beside each other. So whether we're talking about the first and the second, or the 13th and the 14th, n is going to be equal to 1. 1 minus 0, 14 minus 13, n is going to be equal to 1. We get the value of 1 over d, it's 1,000. Lambda is 750 times 10 to the minus 9 meters. And L is 3.0 meters away. Let's find D here, okay? Let's find D right away. 1 over 1,000 is 1.00 times 10 to the minus 3 centimeters. Convert that to meters. Divide by 100, 1.00 times 10 to the minus 5 meters. Right? Divide by 100 to go from centimeters to meters. Multiply by 100 to go from meters to centimeters. Okay, so what do we want to do? Lambda is equal to xd over n times L because it looks like it fits the givens. Rearrange this to solve for x. Lambda times n times L over d. If, right, if L is greater than 10 times x. We got a problem here though. We can't do our check, right? We can't do our check because we don't know what x is. I'll tell you what you could do, but I wouldn't worry about too much. You could go back and say lambda is equal to d sine theta over n and solve for theta as a check, right? Because that's actually really a better check than our rule of thumb, because that tells us exactly what theta is. If theta is less than 10 degrees, we're good to go with the other equation to solve for the value of x. But I'll tell you what, I wouldn't worry about doing a check in this question. If they ask you to solve for x, and there's only one equation that will get x for you, then you have to assume that that equation ends up being valid, right? So don't worry about doing the check with this. You could do it, but don't worry about it. If your only way to find x is with that equation, then that equation must be valid. Just go ahead and use it in that situation. Okay, so let's solve for x here now. What do we got here? Lambda, 750 times 10 to the minus 9, times n, which is 1, times L, which is 3, divided by d, which is 1 times 10 to the minus 5. Is that right? We get 0.225 meters, or 2.25 times 10 to the minus 2 if you want to write it in scientific notation. Doesn't really matter. Sorry, there is a typo there, 2.25 times 10 to the minus 1. Just converted it to scientific notation wrong there. Thank you. All right, let's continue on with our homework now. It was worksheet number 19. We had all or we had the first 8 questions assigned. We're going to do questions 2, 5, 6, and 7 here now with you. Question 2 says the distance between the first order maximum and the third order minimum. Again, we got maximum and minimum. We got to be careful with that. Is 6.17 times 10 to the minus 2 meters. The screen is 1 meter from the slits, and the slits are 2.50 times 10 to the minus 2 meters wide. What's the wavelength of the light? Let's get the value of n here first. Central, first order bright spot, second, third. We're looking for the first maximum and the third order minimum. 1, 2, 3, third order minimum. N is going to be equal to what? What is it? 1.5, good. It's 2.5 minus 1. So n is going to be equal to 1.5. Good. What else we got here? X is 6.17 times 10 to the minus 2 meters. L is 1 meter. And D is 2.50 times 10 to the minus 2 meters. We're looking for the value of lambda. So we want to use lambda is equal to xd over n times L. But we got to do a little check here, right? Is L greater than 10x? 10x is 6.17 times 10 to the minus 1. L is 1. L is way bigger than 10x, right? Way bigger than 10x. So yeah, we're allowed to use that equation. Right, Jimmy? So let's do it then. Lambda is equal to x, 6.17 times 10 to the negative 2 times d, 2.5 times 10 to the minus 2, divided by n, which is 1.5, times L, which is 1.00. And when we do the math there, I think we end up getting that 1.03 times 10 to the negative 3 meters. Right? Typically in these questions, we get 10 to the minus 7 meters because that's visible light. But it is possible to get other colors as well. Now, if I get 10 to the minus 3 for a wavelength here, that's something that on a test, I'd probably just double check because that's not a common answer, but it is a possible answer. It's not like getting 5 times 10 to the 7 times 10 to the 12 meters per second for a speed. That can't happen. This can. This is not all that common. Okay, number 5 is next. This one says light with a frequency of 5.5 times 10 to the 14 hertz is shown on a diffraction grating that's got 6,000 lines per meter. What's the distance between the second order maximum and the fourth order maximum? Okay, let's get that first. Okay, central, first, second, third, fourth order maximum. Second order and fourth order, we'd say n would be 2. 4 minus 2 is 2. My frequency is 5.50 times 10 to the 14, which we're going to convert that to wavelength, right? We'll do that in a minute here. We're going to say 1 over d is equal to 6,000. We're in meters here, lines per meter, so at least we don't have to do that conversion. Convert that to d in a minute here. L is 2.50 meters. And we're looking for x, the distance between them here. Let's get wavelength. 3 times 10 to the 8 divided by the frequency gives me a wavelength of 5.4545 times 10 to the minus 7. And if we flip this over, we get a D value of 1.6667 times 10 to the minus 4 meters. This is what it looks like it fits. Oh, wait a second. We can't do our check here, can we? Actually, we can do a check. This is a different check. We could find the value of theta. Actually, we couldn't even find the value of theta here. How come? Oh, there's a good question. How come we could not find the value of theta with this one? Yeah. No, we don't need x to find theta. We don't need x to find theta using the equation that is d sine theta over n. If we find it the other way, then yeah, we do. You're right. Theta is always measured from what? Theta is always measured from the central max. And here we've got the second order maximum and the fourth order maximum. But you know what, guys? You don't need to worry about it. Like I said in that other question, I think it was question number 1 on page 693. If you have to solve for x, the only way to do it is to use this equation. So it must work. It must be valid. Don't worry about the check when you're solving for x. X ends up being lambda times L, n times L over D. Okay, we got all these values, and when we sub them in here, it should work out to be 1.64 times 10 to the minus 2 meters. Number 6 is virtually identical. So we're actually going to skip going over number 6, but I do want to point out one thing. Okay, it's the same question, essentially the same question at least. You got to convert this to D, you got to convert this to lambda, and you're going to do it the same way as you did in question number 5. The thing you got to be careful of here is the value of n. Central maximum, first maximum, second, third, fourth maximum. We're looking for the distance between the second order maximum and the 1, 2, 3, fourth order minimum. That distance is 2 meters. The value of n that's consistent with that is going to be 1.5. 3.5 minus 2. Okay, so once you recognize that difference here, the rest of the question is exactly like it was in question number 5. Try it again. If you have trouble with it, let me know and I'll go over it with you. But I want you to take another try at it yourself here first. And finally, we have question number 7, which is again the same as question number 5. Just remember that you got to convert to wavelength, like in number 5. Okay, 60 lines per centimeter. That's 1 over D. Get D. 1 over 60 here gives me 0.01667 centimeters. Okay, we got to convert that to meters by dividing by 100. That's going to be what? That's 1.67 times 10 to the minus 2 centimeters. In meters, that would be 1.67 times 10 to the minus 4 meters, right? Divide by 100. So you get your value of D here. And then what? Second order maximum, fifth order minimum. Second order maximum, 1, 2, 3, 4, fifth order minimum. That's going to be n is equal to what? 4.5 minus 2 is 2.5. Okay, once you got that, same as the last question. Same as the last question and the question before. We're good with that?